Eighth graders, day 3, 8th grade science test prep. You will have 60 seconds to read, think about, and answer the question. Your first question starts now. The galaxies pictured above would best be classified as, not much I can say here, but lots of different kinds of galaxies. These are referred to, see how they kind of spiral like this? Scientists aren't very clever when naming stuff a lot of times. They just, name it like it is. So these are what we call spiral galaxies. Two-part question here. A galaxy is best described as a cluster of, well, how many stars do you think are in a galaxy? Um, I'm just going to tell you, it's a lot. It's not hundreds. It's not thousands. It's not even millions. Stars or galaxies can have billions, as in like 500 billion just in the Milky Way. 500 billion in the Milky Way, which is the galaxy we live in. So when you see this picture, that's 500 billion stars. Letter D. Next question, 60 seconds. Begin. To express the distance between the Milky Way galaxy and other galaxies, the most appropriate unit of measurement is the... Well, before we answer, I'll give you a 60-second lesson on why we use different units for measurement. If I'm measuring a human, like height, feet are pretty convenient because we're all around the same number of feet tall. I wouldn't want to measure us in miles because that unit does not fit our size. By the same token, if I had a little bacteria that are very, very small, I wouldn't want to measure it in feet because it doesn't make sense to measure it. So we had to come up with new units, say like nanometers, which are very, very small. So thinking of that, or if I'm driving from Sioux City to Omaha, I don't measure it in inches because the unit's much too small. So galaxies are very, very far apart, so we need a very monstrous unit to measure the distance between them. Meters, which are kind of similar to feet, uh, that doesn't work. Not big enough. Kilometers are not big enough. Kilometers are similar to miles. Light year is the distance that light travels in 1 year, and light moves very quickly. So this is a very large unit. It actually fits perfectly. So when we say something is 10 light years away, we're saying that it takes 10 years at the speed of light to get there. So it's a very large unit. So letter C is the choice. Next question, 60 seconds. Begin. Which of the following sets contains only objects that shine as a result of reflected light? This one, you might have a hard time interpreting what the question actually means, but think of it this way. If you think of heavenly bodies or things that are out in outer space, stars produce light because that's just what they do. That's the only thing they do. Produce heat, light, energy, whatever you want to call it. Everything else, you have to shine light on it to see it. So when you look up at the sky at night and you see the moon, the only reason you can see the moon is because the sun is shining on it. So all three of these answers, choice B, moons, comets, and stars, stars in choice C, stars in choice D, all three of these you can throw out because stars do make their own light and don't need reflected light. So this one, choice A, all three of these, moons, planets, and comets, you need to shine starlight or sunlight on them in order to see them. Next question, 60 seconds. Begin. Which of the following forms of energy is released or absorbed in most chemical reactions? Here's what I would say. There are chemical reactions that produce light. There are chemical reactions that make electricity. There are chemical reactions that make sound. And there are chemical reactions that make heat. So we could find an individual reaction that does at least one, if not all of these at the same time. So which of the four happens with just about every, which is the most part here? It's not light, it's not electricity, it's not sound. Almost every chemical reaction is going to absorb or release some heat. Our choice then is D. Next question, 60 seconds. Begin. As a sample of water turns to ice, one of these four statements is true. New molecules are formed. Well, when water freezes, are we changing the identity of the water? And the answer is no. It's still water. The molecules are not changing, so A is gone. B, the mass of the sample is increased. Mass cannot be created or destroyed in a chemical reaction or in a change of state. So the mass will not increase. It should stay the same. So B is out. The arrangement of the molecules changes. If you think about a glass of water, the water molecules look something like this, and they're just randomly floating around in there. When ice or water freezes, they actually arrange themselves in a perfect crystalline structure. And then eventually what we get is an ice crystal. So the arrangement does change. So our choice is C. Just talk about D for a second. This is actually exactly opposite. Energy is not absorbed, it's actually released. So that is almost true, but we're one word's out of place. So the choice is C. Next question, 60 seconds. Begin. The table below shows the pH and reaction to litmus of four body fluids: blood, bile, saliva, gastric juice. So this would be, so what, how do we know that, so that about gastric juice here? Is it acidic, basic, positively charged, negatively charged? So here's the clues. pH 1.7. So here's what we know about pH. If pH is less than 7, you got yourself an acid. The lower the number, like 1, very acidic. 6, not very, but still acidic. So here we go, we're very acidic here. If it turns red in blue litmus, that's also an acid test. This also indicates with no change here. This is an acid test. So the choice here is we are very acidic. Choice A. Next question, 60 seconds. Begin. Which of the following elements is best able to combine with itself and hydrogen to form large molecules? This is tricky. There's a whole branch of chemistry called organic chemistry. For the most part, organic life forms like plants and animals are made up of very long chain molecules, proteins, lipids, carbohydrates, and things like that. Every one of those molecules consists of a chain of carbon atoms surrounded by hydrogens, nitrogen sometimes, oxygen, a couple other random elements sprinkled in there. But the trick is we have to have carbon and we have to have hydrogen. So to answer the question, the best, and all of these elements can bond with hydrogen. The best atom, though, is choice D, the carbon atom.